Assalamualaikum. Hello everybody. A very good morning to all of you. So welcome back again to our public live webinar. This public live webinar is powered by Feiran Technology Sdn Bhd. Okay, my name is Shahadatul Iskandar bin Rosli and I am the Senior Application Engineer in Feiran Technology Sdn Bhd. Okay, if you are new to Feiran Technology Sdn Bhd is the only licensed, approved and trusted Dassault systems vendor in Malaysia. Alright, we are your one-stop center for all Dassault System Solution Suites. Okay, today we are proudly presenting to you all our topic of the day, CATIA for Manufacturability and Lightweight Design. Okay, this topic will be presented by our application engineer. The name of this application engineer here is Meor.ubaidillah, Mr. Meor.ubaidillah. So I will welcome him to our floor here.
Hello everyone, thank you Iskandar. Okay, my name is meor.ubaidillah. So today I will be delivering the webinar. So before I start, I would like to introduce myself. So I had my degree in Moscow Aviation Institute, Russia, majoring in aeronautical engineering. And then I proceed with my master degree in Glendale University, one of the universities that have collaboration with Airbus in UK for 1 year. Also in aeronautical engineering. And then I joined Feiran Aerospace Malaysia as a design engineer, designing the Dornier Sister Sea-Wing aircraft, which has made its maiden flight just recently. So now I'm joining Feiran as an application engineer, focusing on CATIA, meor, and so on. Okay.
All right. Thank you, Meor, for that brief introduction. So Meor here is our subject matter expert of the day. He is our expert in Dalmia application suites for Dassault Systems solutions. So today, as usual, I'm going to remind all of you that if you have any questions regarding our topic of the day, you can type in or submit your question in the comment area below. And while we going into the Q&A session later, during towards the end of the webinar, I will flash your questions in our session. All right, so that we can discuss the question and answer it together in the session. All right, Meor, are you ready?
Yes, please.
Okay, so over to you, Meor.
Okay, thank you everyone. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for coming to my webinar today. So today I will be delivering on the topic as mentioned by Iskandar, which is CATIA for Manufacturability and Lightweight Design. So without further ado, let's start with our first slide. Okay, before we start, I would like to define to the audience what is the meaning of manufacturability and lightweight design. Okay, so by definition, lightweight design is the science and the art of making things, parts, products, structures as light as possible within constraint. Okay, now why do we need lightweight structures? Okay, in engineering industries, particularly in aerospace or automotive, it is always good when it is light in terms of its better performance as well as energy and material usage reduction. So in automotive or aerospace industry, lighter means lesser fuel consumption. Lesser fuel consumption means lower cost, and this applicable to all industries as well. So how can we make our design to be lightweight? There are multiple ways to use we can use to produce our lightweight design or product for the final products. So the first is we have biomaterial. Designers and engineers are using lightweight materials such as composites as an alternative to metallic structures because it has almost similar strength and stiffness to metal, but it is actually lighter. So the second one, we can produce lightweight design or product by using geometry and function or design process. Engineers are able to perform weight reduction through design optimization. So what does it mean by design optimization? Let's say you have a big block of heavy metallic structure. You can make it lighter by removing some of the unnecessary materials from that structure without compromising its structural integrity. Through this method, we will have a new lighter design with different shapes, but still maintaining the same function of the structure. So we will see how in the next few slides. The third one, we can produce lightweight design or products through or biomanufacturing process. Through correct manufacturing technique, we are able to save some weight without compromising the functions of the structure. We will see an example of one manufacturing process simulation, which can be used to save some weight in the next few slides. Okay, in CATIA, we have dedicated tools, or we call apps and modules, which we can use to produce lightweight design products. Things to note, this is CATIA 3D Experience, which is the latest CATIA software by Dassault Systems. It is a software in a collaborative platform on cloud, which is beneficial for multiple companies' collaboration online, especially during this COVID-19 pandemic. There are plenty of apps built in this 3D Experience platform. As we know, people or industries are trying to minimize the human interaction as much as possible. So this CATIA platform, which is powered by internet, and you can bring it or you can use it anywhere that you want. This application or software will be the new trend in the future. So please pay close attention to what I'm going to deliver here today. There are plenty of apps built in this 3D Experience platform dedicated for lightweight design. But in this webinar, I am going to show 4 different apps which are cognitive augmented design, also known as component functional generative design, composite apps, stamping die face design, as well as reverse engineering app. So the first one is cognitive augmented design, also known as component functional generative engineering, which will be used for reducing weight through design process. The second one is CATIA, has a specific design tool for composite design as well as for its manufacturing planning. The third one is by manufacturing process using stamping and die face design app in order to optimize manufacturing of thinner sheet metal parts. We are also going to see reverse engineering app. This app is used to transform and reconstruct existing legacy product into 3D CAD files for further design validation processes. Moving on to the next slide. So the apps that I mentioned in the previous slide belongs to each specific group used for lightweight design and manufacturability. So before we proceed, let's watch a teaser video to get some ideas on this app's capabilities. Can you play the first video?
Sure, Meor.
We can hear the sound.
The ability to create exciting new products at a faster rate and lower cost. This will change the future of design and engineering. In addition, increased pressure on organizations to reduce carbon emissions has triggered the demand for alternatives to conventional materials to reduce the impact on the environment. Engineers need to design products which meet new demands, reducing weight, cost, and material usage, and maintaining or increasing strength, stability, and safety. The 3D Experience platform offers an integrated environment that will allow you to increase productivity by leveraging the extensive portfolio of apps for the creation and management of sophisticated lightweight product. Lightweight engineering is performed on products, geometry, and function. Cognitive augmented design is a weight optimization solution, also called function-driven generative design. It's a revolutionary approach, allowing you to explore and generate lightweight shape. This design approach starts with the capture of functional specifications, such as geometrical contact, targeted performance, and constraint. Concept shapes are generated automatically to obtain an exact geometric representation that can be easily structurally validated. From a baseline design study, it's easy to compare different alternatives and the resulting performance indicator to select the best concept. Reverse engineering deals with transitions between the digital and physical worlds. The best example is to digitize good existing legacy products and assets that do not have a CAD model. A physical scan allows you to reconstruct the model at the right scale. Boosted by additive manufacturing, the part can be reworked, optimized, and made lighter. Another technique for lightweight engineering is to replace a part with a lower density part and associate the correct material property to the correct part. For composite materials, CATIA provides an all-in-one solution to cover the whole engineering to manufacturing process for creating high-quality composite parts. Even at the concept stage, it delivers tools to cover both the preliminary and detailed design phases while taking into account the product's requirements for manufacturability. At all stages of the design process, the manufacturability of parts can be easily assessed with fiber simulation for hand layup or for fiber placement laying, ensuring the release of a producible composite part with regards to the targeted manufacturing process. Another sheet metal manufacturing process is stamping die. Throughout the conceptual stamping process definition, dedicated robust applications helps the tooling designer in the manufacturability analysis. Operations planning is validated with geometric analysis. As a result, these high-quality surfaces are used directly for the mold and die manufacturing process. In conclusion, lightweight engineering with CATIA has the most competitive products to help you create and evaluate new types of concepts and techniques that will make better, lighter products. Any designer in any industry can now develop their projects efficiently with unique capabilities that gives you the power to save weight, save money, save time, and make the right decisions.
Okay, thank you, Iskandar. So back with my slides. Okay, I've mentioned before, there are three ways to reduce weight for your products. The first one, or I call the first chapter, is by material. So, okay. Okay, so for those who might ask, what is composite? So composite or polymer matrix composite is a thermoplastic material which is the combination of fiber and resin to produce a lightweight product. It looks like and feels like plastics, but its strength and stiffness are similar to metallic structures. It is very light, but at the same time, it is very complex to design and manufacture as compared to its metallic counterparts. It is very hard to understand, predict, design, and simulate composite behavior without proper tools because wrong design and process will cause many problems such as delamination, void, warping, which may compromise the integrity of the final products. But Dassault System has a complete solution to cater all the problems that I've mentioned just now. We have the apps dedicated to design from a single composite, pre-prep, apply, validate the behavior of the composite structure under loads, and eventually to simulate the manufacturing processes. In order to have some idea, Iskandar, please play the second video.
All right, sure.
Okay, so this video is without audio. I will narrate. Okay, as you can see here, we have a spoiler of a car which will be made using composite material, starting from design phase, where it is designed in CATIA based on NACA specifications. Once the design is completed, we can proceed with composite plies definition. Using CATIA composite design app, we can define composite parameters on the spoiler, such as adding composite plies, define its orientation angle, define its stacking sequence in a producibility table, as well as creating complex solid for the laminate, and such as adding honeycomb to the structure. And to validate the composite structure, we have a dedicated app to simulate the peak stress upon strong wind by using computational or CFD method, as well as static stress by using FEA method. So we can validate the structural integrity of the composite part. We have several apps that support composite manufacturing process, such as hand layup, resin transfer molding, tape laying, fiber placement, braiding, and forming. So this app can save you a lot of time and cost. And this app also have more than 500 use cases ranging from aerospace, automotive, marine, energy, and many more. So you can see that by using 3D Experience platform, you can actually simulate the manufacturing process, including the robots that involved in the manufacturing of the composite parts. We have several manufacturing techniques that we can simulate using this software. And you can have all the benefits that is shown in the video. And worry not, because this software has been used widely in Europe, especially by Airbus, Boeing, and many European automotive and aerospace company, marine company, and so on. So this will be the new future for design engineering. Okay. So from the videos, the key takeaways is by using CATIA, we can actually plan composite design starting from preliminary up to detailed design with scalable design approaches. In the same platform, we can save seamless or we can have seamless integration with manufacturing applications to simulate composite manufacturing process. We can also access analysis tools to check structural integrity of the composite parts under loading conditions and rectify the design wherever required. So for reporting and documentation, in terms of drawing and rich document, such as stacking sequence table, plies orientation, information, they can be created and generated using the same app. So these capabilities allows you to have proper planning, detecting potential issues in order to produce right product the first time. Moving on to the second chapter for lightweight design, which is geometry and function, where we are going to see how to reduce weight by using optimization approach. So before we start, let's watch a teaser video. Please play the third video, Iskandar.
Hello, and welcome to CATIA function-driven generative design. In order to be competitive in today's market, design engineers are being required to minimize part weight, maximize stiffness, reduce cost, and optimize material usage. Additionally, along with this is the need to provide the new aesthetics that customers are demanding. Because of this, the design world is rapidly changing, and so are the processes involved. Science-based physics design is producing new materials and new machines to make the once impossible or difficult using conventional approaches possible. However, it's often cost prohibitive to explore these optimized parts due to the difficulty of collaborating across disciplines and using all the different systems and tools that are required. This individual silo approach can cause huge delays and errors in data translation. Optimization has traditionally required experts and has not been available to designers. With niche optimization tools, creating real geometry which can be reused and matured is a long, drawn-out, and error-prone process. For most engineers, it's too time-consuming to create and validate multiple concepts to select from. The result can be uncompetitive, suboptimal products. The CATIA function-driven generative designer role answers these challenges with a new intuitive workflow which allows non-specialist designers to automatically generate conceptual parts from a functional specification. You can start by using CATIA's built-in direct modeling to create a basic shape model or a defeatured dumb model imported from other systems. A quick in-context check allows you to evaluate the functionality of the primitive shape. Then simply provide the functional specification, including the material, allocated space, mechanical interferences, the loading scenario, weight reduction target, and desired manufacturing process. The functional generative assistant makes the whole process simple. First, select the functional regions, then easily create the meshes. Next, simply set up analysis and apply loads, targets, and constraints, and target weight reduction or other types of criteria, such as maximizing stiffness. A push of the button runs the simulation and generates the optimized concept shape. The part can then be comprehensively validated in the context of the previously defined specification. It's easy for the non-expert to create expert results. You can then create multiple variants, and the variant manager allows comparison and trade-off studies by varying the inputs, such as different weight reduction targets, load cases, constraints, and manufacturing processes such as molding, forging, machining, and additive manufacturing. This allows you to compare and assess the resulting mass and other key performance indicators to select the best concept. This means better products due to optimization and increased number of evaluated concepts. Because of the seamless integration across all disciplines within the 3D Experience platform, the part can then be comprehensively refined, validated, and completed collaboratively and in context. Simulations can run to assure part strength and deformations are within tolerance. Real geometry can be rapidly created using CATIA's integrated modeling tools to define cross-section profiles and then seamlessly combine the geometry to create definable and modifiable specification-driven manufacturable models for either traditional or additive manufacturing processes. View the results in the design review to help choose the best solution and manufacturing solution to fit your need. The resulting digital continuity means no loss due to data translation. Using solid geometry throughout allows for very quick updates in case of a design change. With Dassault Systems 3D Experience platform, this continuity is maintained throughout the entire process from design, simulation, through to manufacturing. So to summarize, CATIA delivers a unique functional generative design solution that increases productivity in an integrated set of lean and flexible process-driven capabilities. An intuitive workflow assistant guides each step. You can either model or import and defeature data from any CAD system. Apply loads, boundary conditions, and connections. There's an extensive optimization setup capabilities for frequency, displacement, stress, and manufacturing constraints. Density map display can be adjusted to refine the result and obtain an exact conceptual body. You can easily validate the structural behavior of concepts. Create variants to explore, compare, and assess different configurations against KPIs and select the best concept. CATIA's best-in-class detailed modeling simplifies part refinement. You can reuse the analysis to validate the design at all stages of the process. All of these benefits combine to make CATIA a unique solution that delivers a real competitive advantage to address today's market needs. That brings us to the end of this short webinar, and we hope you found it useful.
Back to you, Mio.
Okay, sorry. Okay, thank you, Iskandar. Okay, so that's how in the video you can have some general idea of how we can reduce the weight using design optimization. For detailed demonstration, I will provide in the next few slides. Okay. So what it is all about? Remember, instead of starting from blank sheets of papers, the main idea here is to start from specification. You have been given an allocated design box or envelopes from the customer or suppliers. You know what are the forces or loads and boundary conditions apply to this so-called design space or design envelope or design box. You know the materials such as stainless steel, titanium, aluminium, polymer, and so on. And you can ask CATIA to propose some concepts starting from those design specification that you have as an input. So this is a typical design process that your customer will be giving to you, which is the design box or design envelopes, and then you have to perform design, for example, of a bracket within that allowable size of design box. Okay. But the new thing about GDE or cognitive augmented design is now you can forget about the sketch, forget about the 3D modeling parts, forget the fillet, forget the pocket, forget the holes. All you need is just a design space or design box or design envelopes. You just give the design space, design specifications in terms of loads, forces, and boundary condition. And as a result, CATIA will generate some concepts, and then depending on the manufacturing process, you specify in order to manufacture the part, such as casting, forging, milling, additive manufacturing. CATIA will help you to process all the inputs and come up with the design output which matches with the constraint of the selected manufacturing process. 3 ways to use component functional generative engineering. You can start from design space, specification, and then CATIA will generate concept, as you can see in the first step or ways. So you start from the actual existing part that you want to modify, for example, and then the design space is just the shape of the actual part, and you use component functional generative engineering to produce the concept shape with reduced weight. Or you start from an assembly, which consists of plenty of components. Maybe you can have 100 components, and you would like to reduce the number of components to reduce the cost of manufacturing and the assembling of these new manufactured products. So these are the 3 scenarios that you can use to minimize the part counts and part weights in your products. So, now I'm going to show to you the demonstration of how this software will work in design optimization. So let's say in a design firm or design house, let's say you guys have a design task, which is product overweight, or design issue, which is product overweight, and your boss comes to you, okay, Mr. Mio, you need to reduce the weight but maintain the stiffness of the part that is located here, which is this legacy part. So this part is an aluminium, and you need to optimize the part by reducing weight into the shape that I've shown in the slide here. So let's see how CATIA will help you to go from this legacy part into this shapes, organic shapes. So it's freedom or it's a freeform shape. And we will use 3D printing technology to produce this because, as you can see from the slide, it is lighter than milling. So please play the demo video, which is the 4th video, Iskandar. We can see the demonstration of how to use the design optimization software.
Okay, this is my actual part, maybe a CATIA V5 part, maybe a step 5 that I receive from my customers. I give some freedom to the part to have a little bit more flexibility in the design. CATIA recognize the mechanical interfaces, which are displayed in blue, which are the link between the surrounding neighbor parts within the assembly. It's finite element analysis based, so I have to mesh the part, but it is really made transparent for end user because this tool is addressing mechanical designer, not FEA expert. So it should be smooth and easy to use. Once this is done, I define my loads. In this case, I define forces at the center of gravity of the 4 holes, which are the mechanical interfaces of a given magnitude. I create another force on another direction with a different magnitude. I will combine those 2 forces in what we call load cases, which are scenarios, where we can use one or the other or 2 forces at the same time. Once this is done, I will now define my boundary conditions. I could have clamped the part, but I will just use what we call virtual bolt, which is a more smarter contact definition, where you define the diameter of the head, the diameter of the nut, and the shear stress and the axial stiffness. Okay, CATIA is smart enough; it can replicate your virtual bolt definition to similar diameter circles inside your part. This is what I do. Now I define what I would like to optimize: maximize stiffness, minimize mass, optimize the eigenvalue frequency. I use in this particular case, maximize stiffness, reduce the volume of the actual design space by 85%. I can select some geometrical constraints. I would like a symmetrical part, even if the boundary conditions in the load are not symmetrical. And then I can also define manufacturing constraints. For the first step, I will say, no manufacturing constraints, create the form that you want. And I run my optimization. So I run a structural analysis. I run an optimization multiple times to converge to a first concept. And CATIA show me this concept. What you see in green is just the boundary between what you can consider empty versus what you can consider as plain. Then the user, with a cursor, can play and get a thicker or a thinner shape. Automatically, in one click, this green finite element representation is converted into an exact solid, what we call the boundary representation solid. And of course, you can, by one click again, because we keep all the specification, loads and boundary condition where they are applied, you can validate the design. Looks like the design is okay. If it's not okay, you can easily modify the shape, and you can also refine the shape if you are satisfied. Now let's say I would like to make a variant. It's no longer a free-form shape that I'm looking for, but I will use a casting process, foundry. So I select my simulation object, copy-paste, create a new object, and just change one parameter. This part is no longer free-form, but it will be casted. So I give a pulling direction, and the CATIA will try to create a shape which has no undercut, no backdraft along the pulling direction. And as you can see, the result is completely different. But in one click again, I get a solid, exact solid, and I can validate. Third scenario, my colleagues from the shop floor, they have additive manufacturing machine. They tell me, Daniel, this is a vertical printing of your additive manufacturing process. Please, can you type in 45 degrees, which are the angle where I do no longer need support, or I need support in the additive manufacturing process. CATIA generate a concept, I validate, and now, very simply, I can enter into the variant manager where I will compare legacy, freeform, casting, additive manufacturing shape. There are some KPI for every single scenario: the weight, the maximum displacement, the maximum von Mises stresses, some other parameters, some other KPIs. I can put priority, weight, to those various KPI, and CATIA will help me to compute the best score and give me some recommendation. Maybe this one is better than this one regarding the priorities that you assign to the various KPI. Let's say I would like to use additive manufacturing shape. I just want first to smooth a little bit the exact solid very easily by just dragging, and dropping line on my tubes. CATIA smooths the solid very easily. It's a very easy tool, very straightforward. All the mechanical designer can pick up and use this tool very quickly. And once the smoothing is done, I just replace in my spec tree the automatic reconstructed surface by the smooth one and update my design. This is what you will see very, very soon. So as you can see, the UI is very simple. It's very straightforward. Of course, I have to mirror the part, update, and then I have to integrate, but it is done automatically, the mechanical interfaces. This is the result of my preliminary design. So from multiple concept, I went to a preliminary design. I can modify this preliminary design, and I can, for example, push and pull on the base mesh of the subdivision surfaces that we are using to create those freeform shapes. As I modified, one-click validation is to check that everything's fine. I'm not sure the part is really without support. Not a problem. Inside CATIA, there is tools to look and display the area where we will need supports, which were displayed in yellow. And here, it's just the experience of the engineer. He will modify a little bit the shape, add some cross members in some particular area to avoid supports. This is not automatically done. It's a mix of experience of the user and our topology optimized additive manufacturing constraint-based software. Looks like it's good. I'm fine with that. Let's double check how this part behave benchmark against the legacy part and some other variant. Looks like it's great. I'm fine with that. But my boss told me you should gain more weight. Still too heavy for me. Not a problem. Remember the line that I dragged and dropped? CATIA automatically created circles. Those circles are parametric circles with a center and a radius. Now I will select some of the circles I would like to further optimize and tell CATIA, okay, those are those 4 circles. You should not go over a given von Mises stress. You should not go over a given max displacement. So it's not only geometrical optimization, it's really finite element analysis based parametric sizing optimization. I run the computation and CATIA, again, optimize no longer the topology, but in this case, the parameters, the value of the parameter, the size of the parametric entities, and give me a thinner design and a less heavy design. This is done in an extension role called function-driven detail refinement, but I will come back to the packaging later on. As a result, you will see displayed in orange the circles that have been optimized. And not only we were able to topology optimize a shape, we are able to parametrically size optimize a shape, even if those shapes are freeform, okay, which is our case actually. So the blue and the green, and the orange are displayed. You can see here the beauty of CATIA at work. You print the part. To print the part, you have to do some modification. So from an engineer point of view, my job is done. I tell my colleague in the shop floor, please print the part. They will have to modify the part, but you are still in the same workflow on the 3D experience platform. Easily, they can grab the part, modify the part. For example, reduce the cylinder diameter because in 3D printing, I cannot get the right specification. So I will make it smaller because later on, it will be drilled on a drilling machine. I will add some over thickness on the flat area because later on, they will be surface mill with a 3-axis machine. But this is easily done. We are within the same exact environment. No data transfer. It's a success. I print 3 parts. The customer is happy. He wants 1,000 parts.
Okay, so as you can see, what I say that I print 3 parts, the customer want 1,000 parts. So it's very easy and very intuitive. Anyone who are not the expert also can master this app very easily. Okay, so using this app, we now have a new design practice workflow, which is very cool and very practical. Just what we had before is we start our design from scratch. By using these apps, it is started from the design space or design box, which envelopes your design structure within the design box, and you can assign all your functional specifications such as loads, boundary conditions, materials, and then CATIA will generate a concept shape, and in a one click you can get a solid here. And then from this solid, you can perform some FEA validation to check for the structural integrity of the parts. And then you can also explore other shape, alternative variants, one for casting, one for milling, and one for additive manufacturing. You can compare them using the thread of study management, wherein you can specify other parameters such as costing, strength of your final parts, and then you are assisted by CATIA to produce the final shapes depending on your manufacturing technique, such as milling, casting, or additive manufacturing, for example. And those are the unique capabilities of CATIA 3D Experience platform, which you cannot get in the current existing CATIA V5. And this will be a revolutionary tools in the future, since it is working on the internet platform, and IoT is one of the pillars in Industry 4.0, and this will be the new trend in engineering industry in the future. Due to this pandemic, people are trying to minimize human interaction as much as possible. So this is a new design flow for us in the future. You can go further, performing your final validation, for example, from your design 3D or from your 3D solid. You can find some maximum stress or peak stress in your structure. You can modify the parameters of your design parts, increase the thickness, increase the fillet. So in order to decrease the peak stress and lengthen the life of your parts. These capabilities can be done in the apps without having so much knowledge in the FEA, for example, because the app is very user friendly and very intuitive. Okay. So next, moving on to the next technique, which is CATIA reverse engineering. Reverse engineering is used mainly for converting legacy data into 3D CAD model, which can be later used for lightweight optimization by using functional driven tool, as we've seen in the previous slide. And you can also use this reverse engineering app to generate a surface for manufacturing and so on. You can see in the next few slides. So now, what does it mean by reverse engineering? The easiest example is, let's say you have a solid part. Let's say you have a mark or a cup. Everything that you have about this cup is just this cup. You don't have the drawing, you don't have its 3D model and so on. How you are going to reproduce this cup or whatever you have, the solid data that you have, without having its engineering data. This is the time where you need to perform reverse engineering to produce 3D CAD model. 2D drawing, and eventually this part can be recreated in digital form. So by using CATIA reverse engineering app, you are able to generate cloud of points. Okay, of course, you will need a 3D scanner where you can scan the mark or the cup, and cloud of points are generated in CATIA. And then from the points, you can recreate the surfaces, eventually 3D CAD data, and you can perform design optimization as well as other files or other operations that you want to create from it. As you can see, this app are used in many industries as shown in the slide. Okay, it is used for inspection, for NC machining, create surfaces, STL in STL format, step format. And then from the data also, you can have a 3D digital mockup to check for assembly, glaciers, kinematic studies, and so on. Okay, and then from the surface reconstruction, you can create 3D model, and then from 3D model you can have virtual reality also in the same apps to see the design review in the one-to-one scales. And then you can perform some structural simulation to check for structural integrity. And lastly, you can perform 3D printing, rapid prototyping of the part. Okay. Okay. Before Iskandar, in order to have some idea on how this app will work, can you play the 5th video?
All right, sure, Mio.
CATIA Physical and Virtual Prototyper. Reverse engineering workflow acceleration is based on customers' requirements in production. To introduce this topic, have a look at the 3 reverse engineering existing methodologies on the market. There are 2 manual methods and 1 automatic. The first manual method, mostly dedicated to mechanical parts, is named surface-based workflow or on-trim approach. After a scan of the data and a zone segmentation, you can get the basic shapes and features based on automatic recognition. Continue in trimming surfaces and can add fillets. The second manual methodology, named curve-based workflow or network approach, is mostly for free-form shapes and generates Class B surfaces with at best a tangency continuity. The automatic method is dedicated for artistic and organic free-form shapes, can also be used for terrain modeling at a larger scale. These methodologies were already available through CATIA V5 capabilities. 3D Experience CATIA introduces a new user experience to increase productivity, enlarge the reconstruction scope, and favor process predictability. 3D Experience CATIA automates the mesh-to-surface process as much as possible and keeps it under your control at any time. Today, scanning device cost has become relatively affordable with great accuracy. For instance, in this video, we've been digitizing blue car by hand and quickly got a mesh with exceptional precision. Since our 2015X release, using a neutral .stl format, CATIA could select and remove unnecessary elements, like the table in this case, with a semi-automated cleaning process. Selection can be made manually or in an automatic mode to accelerate this data preparation phase. Since 16X and 17X, 3D Experience CATIA introduces a new curve network preparation command for even better productivity to draw curves on a mesh. At this stage, it's mandatory to be precise in the curve's definition to reach a high-quality surface afterwards. Draw fillet ribbon lines and connect them together. The connector works between 2, 3, and even 4 ribbons. Any created curve is easy to manage and to make it fit the mesh at the expected tolerance level. The Curve on Mesh tool has completely been reworked and simplified with adapted tools inside the wizard, like checking the curvature, the mathematics, and is able to reach a very high level of curve quality, whatever the mesh quality itself is. The result is an associative patchwork wireframe that you can provide to tools like Curve Network and Surface Network. The new command, Mesh Shape Analysis, is introduced in 3D Experience CATIA in our 2018X to boost your productivity for mesh to Class B process. It's a simple and productive way to segment mesh with colored zones according to curvature change. The manual edition allows splitting or merging areas together with a visual assistance. This new capability is also integrated in the Curve Network Preparation command for even better productivity, helping you position curves. The objective is twofold: segment in zones and better understand the shape from the mesh. The import as file workflow has been improved to reduce the number of clicks during this step. As a reminder, drag and drop is the easiest way to import a file. In terms of packaging, the CATIA Engineering IP Control application is now available in the virtual and physical prototyper role. This improves the 3D printing preparation process. Starting with a product-to-part operation, 3D printing of assemblies is simplified in this data preparation workflow.
Back to you, Mio.
Thank you, Iskandar. So from that video, the key takeaways are, using this app, we are able to reconstruct 3D CAD data into CATIA by using cloud of points. So we are also able to perform modification and addition to the cloud of points before quickly reconstructing the CAD model using various approaches in this app. And the fact that this app has an advanced analysis tool, we are able to inspect any deviation between scan body and as design body for a more precise final product design. And from the scan model also, we can further validate the structural integrity of the parts and found the peak or maximum stresses in the parts using FEA method. And we can modify the design in order to reduce the peak stresses. As a result, we are getting a better design product. Okay, so the last chapter is manufacturing technique. Okay, we are going to see how design for manufacturing be used for lightweight objective. And in this case, we are using sheet metal stamping die face design as our case study. So what is stamping die face design? In other words, also known as tooling design for progressive metal stamping industry. In metal stamping industry, low thickness sheet metal components are stamped and cut or optimized in order to produce lightweight structure in many industries. Iskandar, can you play the 6 video?
Stamping designer role delivers high quality, right the first time tooling by guiding users from the conceptual planning to the detailed tooling design of complex stamped metal parts. With easy to use specialized features and wizards, best practices are ensured while helping the tooling designer to work productively on complex surfaces without being a surfacing expert. In this demo, we'll use the car body in white front panel consisting of two parts, the top and bottom. Here you can see the top and bottom parts. First, we determine the optimal stamping direction by analyzing the geometry, the draft, and the depth of the cut. This ensures the tool design is right the first time. The user guidance wizard makes positioning parts simple. Next, we use a robot to automate the positioning of the part on a press table. The part can now be automatically split and flanges defined by creating curves quickly with the chaining edges function. A simple sketch or 3D curve can be created, which will automatically split the part boundary to create trim cuts. Based on the geometry that has been created with these sketches, the system will define all the trim lines and will create the position of the trim lines that will be used in many subsequent operations. Not only does this accelerate the creation process, but all geometry is associative, meaning it will adjust automatically to any changes, saving a great deal of time. We can quickly define the unfolded surfaces using the geometric algorithm and the K-factor value for the material. The blue area is the initial surface and the green one is the unfolded surfaces. Now we can plan different applications by selecting the elements from the list or from 3D. We can easily preview and change the concept tool design operations in the process wizard. You can see on the right the dialog box provided by the wizard. As you can see, we're not using the specification tree. All the functions and information are inside the wizard. There's also a function which automatically fills the holes, taking into account surface continuity. We can quickly create high-quality surface extensions with tangency or curvature continuity. This reduces the complexity and increases the quality of the surfaces, ensuring that the result facilitates downstream machining of the die. Now we can easily create a wall surface based on a simple sketch. Next, we can quickly define the position of each step individually on a custom press line. Once placed, we can automatically plan the detailed scrap elements based on the conceptual process. Predicted scrap elements are seen here in red. By identifying this early in the process, we're avoiding the cost and delay of late design changes. Now we will illustrate a revision to the part which has a new hole cut out. The overall process is updated. The new element for the cut is created automatically for the newly added hole. In the final step, the die tooling is created using the product template. The front panel die face is replaced in the die template. The result, high quality die geometry and right the first time tooling. You have seen how we can quickly and easily create high quality, right the first time tooling. You saw how users are guided from conceptual planning to detailed tooling of complex stamped metal parts without being a surfacing expert. The easy-to-use specialized features and wizards not only help simplify the task, but also ensure best practices are followed. The whole process takes place in CATIA, which removes the risk and delays of data translation. We have demonstrated the capability in 3D Experience CATIA, but the same capability is available for CATIA V5. Thanks for watching the demo. For further information, visit us at www.catia.com.
Okay, thank you, Iskandar. So from the video, the key benefits or key takeaways that we can take is by having proper planning in CATIA, we can increase production efficiencies. The fact that the software is very intuitive, it doesn't take much time to train users, even non-expert should be able to grasp very quickly. And robust capabilities such as parametric design with respect to company know-how, design template, user can easily and quickly perform design changes within the software. And the software also equipped with geometric and formability analysis, which allows you to detect any design flaws and rectify them spontaneously. As a result, we will be able to get high quality surface result, which can be used directly for manufacturing process such as machining and so on. Okay, so to summarize my webinar today, the lightweight product an objective in all industries because lightweight products gives you better performance, lesser fuel or energy consumptions, as a result saving costs on operation. Lightweight product also can be reproduced by correct materials utilization by using light materials such as composite, design processes by optimizing the parts for weight reduction, and by manufacturing processes such as sheet metal, hydroforming, stamping, and dyeing. CATIA 3D Experience is on cloud platform which uses internet and provide a platform for stakeholders, OEM, suppliers, collaborators, and many different domains such as manufacturing, project management, design entities to have a seamless collaboration within the same platform. So to know more about this software and maybe you need some more training or anything, you can simply contact us in the information that I've provided in this slide. Okay, thanks for your attention. Back to you, Iskandar.
Okay, thank you so much, Mio, for that wonderful presentation. Okay, everybody. So we are going to take a short break, 1 minute break, for us to look at the questions given in our comment area. And we also have some questions given in our contact numbers. So we are going to go through that, and we will come back later during our Q&A session with Mio. All right. So have a short break of 1 minute by this short video. All right. We will see you back again in our Q&A session. Okay, welcome back to our Q&A session of the day. Okay, hold on, I will bring back Meor into our stage. Okay, hi Meor.
Hi. Hi, Is.
So,
Thank you for having me today.
yeah, it's my pleasure. Okay, so we have some questions in our comment area, and we
Okay.
also have some questions in our WhatsApp. But before we address those questions, I need to highlight this technical issue that we encountered today. So regrettably, YouTube cannot streaming our video today very well as compared to our previous webinar. I'm not sure why, because our streaming health is excellent. If you want to know, our streaming health is excellent, but the streaming keep on breaking up intermittently for the viewers. So we are regrettable. We are regrettably informing all of you about that, and we are sorry for any inconvenience caused by those technical issues. But hopefully, right now, the streaming feed is stable, and we can proceed with our Q&A session of the day. Okay, Mio, for the first question given in our comment area below, it is coming from Danalitika. I will flash this question in our main stage. Okay, let's see. All right, this is the question. Now, can you see this question?
Yes, yes, yes.
All
Okay,
right.
so
How can we address this?
this is actually a very good question. Okay, most of the manufacturing product comes from design phases, as you know, because from what I can see in this question, ERP is used in manufacturing domain, while CATIA is used in design software. Okay, how would these two interrelated? Okay, as we know, most of the product before they enter into production, they need to be designed in design phase. So in order for the designer to have a proper planning, to have a simple design, as simple as possible to reduce manufacturing steps or processes. So design phase is very crucial before it is entering into production. So one need to have proper apps in order to plan and design the product before it enters into production. So to answer this question, design phase is very crucial and very related in the product life cycle, and manufacturing will have input from design phase or design domain in order to produce the product. So the planning must be proper and in place since the design phase before it enters into production. That's how I can answer this question.
I think I can add some points on top of that. You have mentioned during the presentation that we are employing the 3D experience solution sheet, right? So let
Yes.
me get back those facts or those points into our screen. Okay, as you can see below on the moving text below there. So by using 3D experience, we actually combine these 4 sections commonly used in any factory or any industry. So we have the sections for modeling and analysis and simulation and collaboration. So by employing all these 4 sections inside our platform, we can further increase the efficiency in manufacturing in order to utilize the ERP more efficiently. Okay, so I think we can go to the next question, right?
Okay. One of the
Right.
solutions. Which one?
The second question. That is the first. This is the second question.
Okay. Okay. How can
Okay,
CATIA
how can
address
I
the
get
need
that?
for lean manufacturing, reuse, and standardization of design engineering? Okay. So to answer this question, we have a specific app in 3D Experience platform, which is the EKL, CATIA EKL, or Knowledge Share Know-how, which the designers can create design template and perform some design automation. So by accidentally of a button, the design can be reproduced according to the design template created using the EKL software. So all the standards and and so on can be created using the app, and then the implementers can simply click one button. All the design will be generated according to the standard, and can be used for drawing generation and documentation for manufacturing. For lean manufacturing, I mean. Okay,
Okay. Yep. I want to further in on the points of EKL in CATIA. Actually, EKL is not a new thing in CATIA. EKL has been there since CATIA V5, but the sad thing is not that many engineers out there is using EKL CATIA efficiently, or they don't even use CATIA EKL. But if anyone is interested in scripting their EKL script in CATIA, I have produced a number of videos inside this channel, inside this YouTube channel. You can go to my channel here and browse for the video relating to EKL scripting. I go through step-by-step process, assuming the viewer have zero knowledge of EKL. So I produced the video in a very tutorial-based method. Okay, so moving on to the next question. Okay, we also have a question from the Nalitika. I think this question has been answered indirectly during your presentation, right?
Yes. Okay, how CATIA support mobility and portability? Okay. As we know, in my presentation, I have shown that, or I have spoken about the 3D Experience platform that is working on internet platform, which can be accessed using different devices or gadgets such as laptops, iPad, and any tablets that you have at home. You can access anywhere or wherever you want, whenever you want, provided that you have internet connections. And let's say if you have customer from overseas, from Germany, and you are working on your design project in Malaysia. So previously, what we did is we designed our product in silo or offline, and then we send the Google Drive or through email. We send the data to the customer, and then only the customer will be able to see the product or the design that we have produced for them. Nowadays, we have the experience platform where the customer and the design house can have a mutual data repository. What you have is only, or all you need is just login credential, and then you guys, as a designer, can upload your design work into the platform, and the customer will be able to see the design products in real time. So without having to have to send through emails and Google Drive and so on, you can see the design product real time anywhere you want, anytime you want, provided that you have internet connection. But let's not forget that CATIA 3D Experience also can be used offline. You can import the license offline for 30 days, and then you can perform any design work that you want. If let's say you don't have internet connection, once you got connected, you can simply sync all the data, and the data will be reflected in the customer side real time. So this will be the new revolutionary tools for engineers or designers in the future. Since we have a pandemic, people are trying to minimize the human interaction as much as possible, and this will be the tools of the future. So that's how I can answer the question.
Okay, I think one of the points here that we need to take note of is during the presentation, meor has already presented one of the capability here is generative design, whereby we can create our design, our 3D model for 3D printing purpose or for 3D printing method. So by that said, I think we can also use that method to address this mobility and portability issue, because we can create the design here virtually anywhere on the world, and we can just submit the design to the 3D printing machine, and we will be printing the product for us. Okay, Neo, I think we can go to the next question.
Okay.
Let me see. Okay, we have a question from Master Rider here. In your experience, what would be the greatest challenge in composite manufacturing?
Okay. For me, for composite manufacturing is you have to have an idea on how to have the perfect manufactured composite product, because composite manufacturing is very hard to analyze, very hard to predict its behavior. So normally in manufacturing module or process, you will have some problems such as void accumulation, delamination on the composite structure. So what is critical is one of the critical issues that you have to address during design phase is you have to be able to see how your layout process will not cause any air trap or void inside your composite structure, which may compromise your structural integrity of the end product. And this problem can be solved using CATIA or 3D Experience platform apps, where you can see the simulation of the manufacturing process, and then you can see the issue prior to its entering into production. So one of the critical issue in composite manufacturing is to make sure that the product does not have delamination, air trap, which may compromise the structural integrity. So this can be solved using the CATIA tools to have proper planning and simulation before it's entering into production. So that's the greatest challenge that I can address now. There are a lot of challenges in terms of MRO maintenance of the composite structure, because unlike metallic structure, you can see the dents or damage visually. While for composite structures, it's very hard to predict the damage. You can only see the damage when you perform some ultra UV scanning, or you can perform some many entity tests to the structures. Then only you can see the problem. So this behavior is very critical for us to understand, even during the planning stage and design phase, to make sure that our structures will end longer, and yeah, that's
Ubay, what is your field of study in your master degree?
okay. In my master degree, my thesis is about finite element analysis on the tapered composite structure, which focus on aircraft wings. From there, I perform ply by ply simulation, ply orientation, and I validate the structural integrity of the part. And from there also, I managed to simulate the behavior of the composite laminate in order to prevent the delamination from occurring in production. So I can justify that the delamination and air trap is one of the greatest challenge for the manufacturer to face, because this problem will jeopardize the structural integrity of the composite parts. So we have to understand that in order to prevent this from happening, we need to have a proper planning even during design phase and simulation phase.
All right, so I think that's what our solution is capable of, right? We can
Yes.
design the composite layer and layout configuration precisely.
Correct. Yes, and then even we can have manufacturing simulation in 3D Experience platform, and it is seamless between design and manufacturing domains. Seamless integration, no need complex data transfer. So it's very good for industry to use this software. I can justify it.
Alright, so moving on to the next question. I think I will go to our audio question that is given via our WhatsApp channel first before we proceed with the rest of the comments here. Okay, bye.
Okay.
Okay, let me see where is the audio recording earlier. I'm not sure if I play it here, you can hear it over there. I will try to play it here and give a response whether you can hear it or not.
Okay.
Okay, hold on.
Assalamualaikum, selamat pagi. Terima kasih.
Can you hear it?
Encik. Soalan saya berkenaan ada some exercise tadi. Tak ingat nama instructor tu ada buat optimization for the parts kan. And from the legacy components to additive manufacturing type lah. Jadi in our current fast production line tu, I see the component produced by additive manufacturing too. If compare the lead time required to produce, would it be faster, or do you see any challenges as compared to producing the legacy part? Because obviously the legacy part is simpler to fabricate. Itu soalan saya. Terima kasih.
Okay,
Okay.
can you get the question? I
Yes,
think there
I
are
think-
two questions in that one audio.
Do you want to try to answer first? Because from what I understand, the question is about the lead time that additive manufacturing is having, which is higher as compared to conventional methods such as CNC machining and so on. But during the demonstration, I've only shown the manufacturing process only for additive manufacturing. We can have multiple more process can be simulated using the app, such as milling, CNC machine, milling, casting. So it depends on how you select your manufacturing process, and then CATIA will generate the concept shape based on the manufacturing process that you have specified. So I understand that by using additive manufacturing, it is often quite long, but quite long to produce. But we need to understand that as compared to milling, additive manufacturing saves a lot of material, because milling or CNC machining will remove a lot of waste because it cuts material. So for additive manufacturing, additive, it adds material according to the design, and it is very suitable for prototyping and so on. But using that part, you can using that part that I shown in the video, I think you can simply use milling, which is also part of the apps. You can simply specify milling manufacturing process, and then the CATIA will generate according to your generate this concept shape according to your manufacturing process specification. So you can also maintain the same legacy process to produce that part. No need to you have a lot of options in the apps also.
Okay, I think for my take about that question is there are two points that we need to consider. The first one is as you said, we take the legacy part and identify the components constraint or design envelopes, and then we use that design envelope solely to recreate a new configuration or new design configuration, whether it be milling or 3D printing, etc., or forging, etc., right?
Yes.
So that is one take for it. Another take is if you want to use the legacy part, you already have the legacy part, but you don't have the legacy data related to it, such as the 3D drawing or 3D parametric design inside your CATIA library. So you need to reproduce that. So there is a way using 3D scanning, but I think for 3D scanning, it really depends on the capability of the 3D scanning hardware that you use. So some of the hardware for 3D scanning, it directly gives you a clean data cloud points. So that is very quick solution to recreate your 3D parts. But not all industry are having that sort of hardware. So in that case, maybe you can opt to the first method that has been presented by Ubay in this presentation, which is you identify the components, constraints, or design envelopes, and then let CATIA propose the new design for you. I think for me that is the 2 points that we need to cover in that one audio, in that one question.
Thank you, Iskandar.
Again, okay, moving on to our comments. Okay, we have here a question about composite, which relates to delamination, which is a common occurrence in composite material. I think you can refer to our communication, Ubay, for this question.
To answer the question, maybe we can have a specific webinar for this on Simulia, because this is quite a long answer for this question. Yes, I think we need a specific session to answer this question.
Yeah. The short answer is for CATIA to simulate a delamination, it is not possible. CATIA will not be able to simulate the delamination, but if you see the moving text down there, in 3D experience, we also have analysis solution sheets and simulation. So we can use Simulia to simulate this delamination of a composite structure. Okay, but as Ubay said, we probably need to have a different webinar for it, solely focusing on the delamination process of composite material. All right. Okay. The next comment, I received this question via WhatsApp, so I just copy paste it into our comment area so that it's visible to all. So it's related to the stamping process. Can CATIA predict tear or wrinkle in the part before it constructs the addendum as a result of part thinning during stamping?
From the video that I've shown, the CATIA have a geometric analysis tool in order to simulate the shape before it enters into production. So, which means CATIA is able to simulate the possible wrinkle and tear in the part, because this wrinkle is actually caused by poor shapes, orientation or layout, and this can be minimized during geometric analysis tools prediction in the software in the CATIA. Then you should be able to predict it before it actually happen. So you can contact us in the contact info provided. Maybe we can discuss further on this topic, or maybe you want to have some solution in order for you to have some ideas on which solution to choose to address your problem in manufacturing.
Okay, all of you can see our contact details in the video description below, and we will attach our personal email also later in the description. Okay, the next question. There are a lot of questions in our session here. I think it's very good that we have this interactive interaction between our audience. So the deck angle question. Okay, for my take here, CATIA cannot identify the dead angle. For CATIA, specifically for CATIA, we can identify the specific draft angle, cut, and depth analysis. But I don't think we can identify the dead angle for stamping components with respect to stamping angle, of course.
Yeah.
Right? Right.
Yes.
Sorry.
Yes, correct. Actually, in CATIA, you can, as what Iskandar said just now, the CATIA will be able to predict the draft angle and so on, and you can modify the draft angle. Actually, during your design process, sometimes your supplier or OEM will give design specification. So you should use all the data given in order to prevent that angle, or maybe anything that is causing problem in you can use all the engineering data that is given by the OEMs for your design in order to prevent all the possible problem in the manufacturing. So
Yep.
CATIA,
That relates to the EKL portion that you talked
yes,
about in the
yes,
beginning.
correct.
Okay. Right. The next question that also coming from our WhatsApp. Has CATIA V6 been launched in Malaysia? Difference between CATIA V5 and V6. I think this is a very
Long
generic
answer.
question. Yeah, long answer.
Long
But the short
answer.
answer is
Yes.
we as Feiran Technology Sdn Bhd caters for both, right?
Yes.
CATIA V5 and CATIA V6, and
And the first one
also
is
the 3D experience.
experience. Yes, correct. Actually, this demonstration shown using CATIA 3D Experience, which is the latest version of CATIA, and V5 and V6 is actually before CATIA 3D Experience. And if you want to have more information about this, we have a long answer, and you can contact us in the contact info provided.
Yep. Yeah, because the question regarding to difference between CATIA V6 and V5 and V6, we have a
Very long.
list of them, right? We have a
Yeah.
table of differences,
Yes,
so
correct.
it's not possible for us to cover each item in the table here.
Yes.
Okay, can CATIA suggest press machine tonnage for a particular deep draw? I think we have a function or apps in our solution which call fast blank. Okay, let me check. Yeah, it's called fast blank simulation or auto form. So we can produce a suggestion of press machine tonnage using this particular application or function, but I think this also needs a separate webinar session by the subject matter expert of this particular topic. Okay, I think if we have such a webinar addressing this topic, we can call to focus this particular questionnaire to attend our session in future. Okay, let's see the rest of the question given here. Okay, I think we can cover last question. Okay, what is your
Okay.
take about this question?
I think in autoclave we have heat and pressure applied to the laminate. So we have tools called Simulia where we can perform some thermal analysis and on the composite structure or composite laminate. Then we'll be able to see how the composite react to heat and how the composite react to pressure. This can be done using Simulia apps in 3D Experience platform. So yes, to answer the question, whether CATIA cannot, but we have a analysis tool which is called Simulia that is able to predict or analyze or simulate the heat analysis and pressure analysis upon your composite structures, and then you can see how the structure react to these parameters. Okay, so it is possible in 3D Experience platform Simulia application. Yes.
I think that's what we can cover for today. We have already exceed our 1 hour session mark. For your information, we are at the 1 hour and 30 minutes. So I think we can wrap up our session for this week's webinar. And if you have any further questions related to this topic, you are always welcome to submit your question letter inside our comment area below, and we will keep on monitoring this live recording in order to get any feedbacks from the audience in future. Okay, Ubay, if you have any more remarks to make before we wrap up the session.
Okay. Any question, you can simply contact us using the contact info provided, and maybe Iskandar can put in the description our contact information. So you guys can simply contact us through that contact info, and we can answer all your question and concern later.
Yeah, sure.
Okay.
Yeah.
Okay. Thank you, Iskandar.
Yeah, thank you. Bye.
Thank you.
Okay, guys. That's the end of our webinar session for the day. I hope it is beneficial for all of us. I can see there are some typings are going on in the comment area, but you can submit the question and we will revisit the live recording later, and we will share the answers to the questions that you submitted after this session ended as well. So no worries, we will continue on reviewing our methods in delivering our webinar so that it becomes efficient to all of us, especially to the viewers. And as I mentioned, it is regrettable that this webinar today is having some technical issues, especially coming from the YouTube itself. But hopefully in future we can overcome these technical issues and come up with a better webinar sharing with all of you. With that said, I thank you for attending our webinar and hope to see you again in our future webinars. Bye.